Hello class, in this video we're going to solve exponential equations. So I'm going to start by dividing this one by 20. The idea is that we're going to use logarithms to undo exponents and solve from there. So this cancels. I get 1/2 to the power x divided by 3. Oh no, sorry, let me make an adjustment here. It's not working out too well. Oh, go back to my pen. There we go. Make sure you have a calculator ready. Okay. We're going to go ahead and take the logarithm of both sides. Okay. So I get x divided by 3 times. Make sure my mind isn't all here right now, so forgive me. The natural log of 1/2 equals the natural log of 1/4. Now I'm going to go ahead and divide by natural log of 1/2 like I would any other constant. And make sure your calculators are ready at this point. So the natural log of 1/4 divided by the natural log of 1/2 is just 2. So I got x divided by 3 equals 2. Then we go ahead and multiply by 3. We get x equals 6. The other thing we could have done here, we had 1/2 to the power x over 3 equals 1/2 or 1/4 is recognized that 1/4 is 1/2 to the second power. And then you can drop your bases and have x divided by 3 equals 2. And then that's exactly what I had here. So keep an eye out for moments like that. It can make it a little bit easier. Okay. Go ahead and try another example. On this one, we're going to subtract 6. Generally, I hope we can see by now that the process is going to be that we want to get the exponential part by itself. Minus 1. Negative 58 minus 6 is negative 64. And then we're going to divide by negative 3. We get e to the power 9x minus 1 equals 64 over 3. Now, on this instance, we're definitely going to want to use natural log, because the natural log and the e will cancel out. The exponent will come out, and then this will cancel, and we're just left with 9x minus 1 is equal to the natural log of 64 divided by 3. And while natural log of 64 over 3 may look kind of funny, it's just a regular algebraic equation from here on out. Add 1. We get natural log. I'm going to wait till the very end to do some calculations so that's as exact as possible. And we get x equals, go ahead and type that in. We got the natural log of 64 divided by 3 plus 1. And all that divided by 9, we get about 0.4511. As usual on homework, make sure you are following instructions when it comes to decimals. Usually it's to the thousandth. All right, now this one's kind of tricky. So this one we're going to take a little bit more slowly. I am going to start by multiplying by 2 because I want to get rid of that fraction. Cancel, I get e to the x minus e to the negative x equals 10. Now, this next step is kind of crucial, and you'll see why I'm going to do it. This is one of those instances where I like to explain what I do after I do it so you can see the benefit of it. I'm going to multiply everything by e to the x. Okay. Now, as I distribute this in, I just got to think through my properties of exponents. They're the same bases, so it's e to the x times e to the x. When we're multiplying like bases, we just add the exponents. So we get x plus x is 2x. Okay. Then we're going to distribute here. We got e to the negative x times e to the x. Once again, we will multiply like bases. And we got negative x plus x is just 0. And then e to the 0 is 1. And then when we distribute it here, it's just a constant. So this is 10 e to the x. Now the next thing I'm going to do is I'm going to go ahead and subtract 10 e to the x, move it to the other side. Now keep in mind, these are not like terms here, so we can't combine them. So we've got e to the 2x minus 10 e to the x minus 1 equals 0. Now, why did we do all this? Let me fix that. That's a little sloppy. Okay. Well, if we look past it, let's rewrite it. I have e to the x squared minus 10e to the x minus 1. We have a quadratic in the form of e to the x. So we can use quadratic formula. Our a would be 1. You could try factoring, but in this case, factoring is not going to help us. b equals negative 10, and c equals negative 1. Now, I'm kind of running out of room here, so I am going to kind of simplify everything. Negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 1, all divided by 2 times 1. So we get 10 plus or minus. We get 100 plus 4, so that's root 104. So 104 simplified as a radical. I know it has a common factor of 4, so yeah, it would be 2 root 26. Okay. All over 2. And then these can cancel. We get 5 plus or minus root 26. Now, here's the thing we have to keep in mind, because this is e to the x. Okay? E is a repeated multiplication of the number 2.71. So what we're looking at is taking two numbers and determining which one of them is positive. Well, root 26 is a little bit more than square root of 5. Now, you can just type these individually into your calculator and find out which one's positive, but logically, root 26 is a little bit more than 5. So if we do 5 minus a little bit more than root 5, then we get a negative. So we are going to get rid of the negative. Whereas with the addition, we're just adding two positives together. So that's all good. And then we finish it by taking the natural log of both sides. And I'll write the final answer up here in green. X is equal to the natural log of 5 plus root 26. All right, so let's go a little bit into logarithms. We have a common log here. Remember, when we have a log with an absence of any base, that's a base 10. So we can get rid of it by taking raising these as powers with the base being 10. So that cancels, and we're just left with x squared, and 10 squared is 100. And we take the square root of both sides. So we get x equals plus or minus 10. That one's pretty straightforward. And then finally, let's look at logarithms with some properties of logarithms. So let's recall that we have a property that says we can take this constant and move it into the exponent. We also are adding two logarithms. Anytime we're adding two logarithms, we can combine them into one logarithm and multiply their arguments. So this would be 3x minus 2 times x minus 1. And this equals the natural log of x squared. Now we're going to do a couple things simultaneously here because I don't have a lot of room here. I'm going to FOIL what's in the argument here. And we're also just going to drop the logarithms because the goal when you're solving logarithmic equations is to come to a common logarithm on both sides, and then you can just drop them. Why can you do that? Well, like we did in the previous problem, just take the base of the logarithm as the base of the new exponential, and they effectively cancel out. So we get 3x squared. We're going to get minus 2x minus 3x, that's minus 5x, and then plus 2 equals x squared. And then you can probably see where we're going from here. Subtract x squared. We get 2x squared minus 5x plus 2 equals 0. This actually, I believe, can factor. Let's see if we do multiply to 4, add to give me negative 5, that'd be negative 4 and negative 1. We wind up with x minus 4, x minus 1, divide by 2, but we're solving for it, so we get 2 here, and then we'll get 1/2 here. Okay. Now, when you're coming to logarithms, you always want to check your solutions because a logarithm cannot have a negative argument, at least within the real world. So plug in 2. We got 3 times 2 is 6, minus 2 is 4. Okay. And then 2 minus 1 is 2, or is 1, pardon me. That's just 0. So we got logarithm of 4, and then we've got logarithm of 4 on this side. So that's good. Okay, and then 1/2. The problem we run into with 1/2 is we get to this one, 1/2 minus 1 is negative. And again, logarithms cannot have a negative argument, so we want to get rid of that one. That's an extraneous solution, something that we picked up along the way. Thanks for watching.